Hi, y'all. So in this video, we're going to do some graphical analysis of velocity, or at least we're going to start to learn how to do it. Um, so um, in order to get an idea of the velocity of an object, what I can do is I can graph its position versus time. So when I say position versus time, that means position along the vertical axis and time along the horizontal axis. So I can just, maybe draw out some dots there, some data where my object might be, and then connect the dots. We remember from the equation that our average velocity is displacement over time, and in this case, it looks like our displacement over time is going at a constant rate. Um, so what we can do then is realize, well, wait a second, delta x, well, that would be the rise when I go from one position in x to the other along the vertical axis. And then my delta t would be the run. So really, when I'm talking about velocity, I'm talking about the slope of a position versus time graph. All right, so let's think about that some more. If I've got maybe a really high velocity, then it's going to have my position versus time graph would have a large slope. A low velocity would be a smaller slope. And then what about that one right there? Well, that's a negative velocity. Maybe my person is moving to the left. If we consider it to the right to be positive, then my person might be moving to the left at a constant speed. And that would be a negative velocity. Of course, velocity can change during the motion of an object, so we can start it slow and then speed up. And then how do we indicate that? Well, if we're dealing with vectors, then when we start out, we've got a small vector. With we continue moving, where our vectors get bigger and bigger. So we keep in mind that when we draw those vectors out, that our arrows need to get bigger. But typically, when we talk about velocity, we're talking about instantaneous velocity rather than average velocity. So a velocity at some specific moment in time. This is definitely true when we've got an object that's velocity is changing. If we're talking about velocity, we're talking about maybe the initial velocity or the final velocity, or maybe the velocity at some moment in between. So let's take a look at this position versus time graph. So on this position versus time graph, it's not a nice straight line. It's got a bit of a curve to it. But what happens if we want to figure out the velocity at some specific moment, maybe right there? Well, it would be nice to be able to figure out the slope of the line. So how would we do that? Well, can we just use the average velocity equation to maybe figure out what this would be? Well, let's see. Average velocity based on what? Based on what delta x and what delta t? If we choose those two dots, well, we get one value for velocity, for slope. If we chose these two, we get another. But what's best is really to try to draw in a tangent line right at the curve. So a line that just barely touches that curve that intersects with that dot, a tangent line. And that tangent line is actually going to show us the true value of the velocity. You can see that, all those different approximations come up with different values. The tangent line is the true value. Okay. So what's the take home from that? If we try to use the average velocity equation, our results can't necessarily be trusted. So if we're talking about velocity, we need to make sure we understand exactly what we're talking about. If we're talking about instantaneous velocity, we can't conflate that. We can't mix that up with average velocity. All right, our correct velocity is going to be the velocity from the tangent line. That's the instantaneous one. All right, short and sweet. That does it for this one.